Today we start Unit 4, Congruent Triangles, with a lesson on congruent figures. What are congruent figures? Two geometric shapes are congruent, I'm going to abbreviate it with our symbol there, if they have exactly the same size and shape. Now that's not to say they can't be turned differently from each other, but they have to have the same size and shape. So we're going to say congruent polygons or figures, polygons or figures, have congruent corresponding parts. So the parts that match each other are the corresponding parts, and we've learned about corresponding angles and sides before. And this is where we have to keep in mind that when we're naming congruent polygons, we have to list the corresponding vertices in the same order. So for instance, if I look at this example here and I tell you that this quadrilateral ABCD is congruent to this one over here, I got to make sure that vertex A corresponds to vertex E. All right, and I can see they do look like they're in the same location on my quadrilateral. Vertex B would have to correspond to vertex F, and so forth for all of them. Okay, so when I name the corresponding sides, I have to make sure the order is correct too. So the side AB, here's AB, correspond to EF. Well, I know A corresponds to E and B corresponds to F, so I do know that side AB is congruent to EF, and so that's the way we have to go. Also, the angles have to be corresponding. Angle A corresponds to angle E, angle B corresponds to angle F, C corresponds to G, and D corresponds to H, and each set of those corresponding parts will be congruent if the polygons are congruent. Okay, so let's take a look at these two triangles here, and let's see, name the congruent parts of the triangles and write a congruence statement. And it looks like everything is labeled. All the sets are labeled as congruent. So we're going to tell all the things that are congruent, and then we're going to write this triangle is congruent to this one. So let's start with angle A. It's got the 3 marks on it. So angle A is going to be congruent to angle P, because angle P has the 3 marks. Angle B is going to be congruent to the 2 mark one down here, which is angle Q. And angle C has only 1 mark, so it's going to be congruent to angle R because angle R has the same marking on it. Okay, how about the sides? Well, let's start with AB. AB. So I'm starting at this angle here, the 3 mark one, so I'm going to have to start. So I go from the 3 mark to the 2 mark angle, so I got to do the same thing here. So AB is going to be congruent to PQ. And why don't you pause right here and you name the other 2 sets of corresponding sides, and then see if you can write the congruent statement about the 2 triangles. Okay, so here we go. I left off, so let's look at side BC. BC starts at angle B, goes to angle C, and that's the 2 mark. B is the 2 mark, so I got to start at Q and go to R. So BC is going to be congruent to QR. And then finally AC. A's got the 3 marks. C's got 1 mark. So I'll go from the 3 mark angle to the 1 mark there. So AC is going to be congruent to PR. And then finally, when I name my congruent triangles, I just got to make sure I remember, look, angle A corresponds to angle P, so they have to be in the same place when I name the triangles. Angle B corresponds to angle Q, so both of those got to be in the same place. And angle C corresponds to angle R, and so I do have a good congruence statement there. Order definitely matters. You've got to be careful. Okay, what do we got here? In the diagram, DEFG, polygon DEFG is congruent to KLMN. So find the value of both X and Y. So if you need to, go ahead and pause right here and write down all the corresponding parts. So for instance, I know that angle D is congruent to angle K. I know that angle E is congruent to angle L. I know that angle F is congruent to angle M, and I know that angle G is congruent to angle N. And you can also do this for the sides if you need to till you get comfortable. So I'm going to start by finding Y because it's one of my angles. It's in angle L, and I know that L right here is congruent to angle E. So what's the measure of angle E? 111. So 111 equals, because I know if they're congruent, their measures are equal by the definition of congruence. So 111 equals 5y plus 6. So if I subtract 6 from both sides, I get 105 equals 5y, and therefore y has to be 20. That's an arrow, not 7y. I got myself confused. Let me fix that a little bit better. That was supposed to be an arrow, but it looked like a 7. That tells me that y, when I divide both sides by 5, has to be 21. Okay, I got to find x. Well, x is inside mn. mn. So if I look at mn up here, I know it's going to be congruent to fg. So what is fg? Fg is 12. I got to come over here for this. So mn, which is 5x plus 2, I know that mn equals fg because they're congruent, so their lengths are the same. So 5x plus 2 is going to be 12. 5x is going to be 10. Therefore, x is going to be 2. So that's what we have to do there. All right, let's see what we got next. Oh, here's an example. Finding congruent triangles. Are these triangles congruent? Well, I want you, well, let's just do this together. So I know this, the only thing that's missing is this angle right here. Well, I do know, and I'm going to have to put 3 marks on that. I do know that these two angles are congruent. So assuming they're corresponding, then I do know that I have congruent triangles because this is congruent to this, and this side is congruent to this side. So let's name our congruent triangles. Why don't you pause here and you try to write the congruent statement. Okay, it's going to be like that, right? Because angle A corresponds to angle E, angle B corresponds to angle D, and of course angle BCA corresponds to angle DCA. And by the way, it's going to be, you can't just call this here angle C because you've got 2 angles there. So what you got to do is you got to say angle ACB. C is our vertex. Angle ACB is congruent to angle ECD. So even when you name the angles and the sides, those have to be in order too. So for instance, if I was going to talk about BC and CD, I would have to say BC is congruent to DC because I got to have my corresponding angles listed in order. D corresponds to B, and of course C corresponds to itself. Order matters so much. Okay, triangle sum theorem that we learned last time. The sum of the measures of the angles in a triangle is 180 degrees. So now we have a corollary and a theorem that follow from that. So the corollary, a corollary, guys, is just another theorem. It's another theorem that we could prove using other theorems. So we're going to use it just like we use theorems and postulates. You're going to make flashcards for them. So here we go. The acute angles of a right triangle are complementary. Okay, and of course I know that the other 2 angles in a right triangle will always be acute. And so what I have right here is the measure of A plus the measure of angle B is going to be 90 degrees. They will always be complementary because I know the sum of those measures has to be 180. And then we have this great theorem here called the third angles theorem that says if 2 angles of one triangle are congruent to 2 angles of another triangle, which is just what I have here. Look at these. Those 2 angles are congruent to those 2 angles, and if I know that, then the third angles are also congruent. So because those two sets are marked, I know that angle C is congruent to angle F. So if angle B is congruent to angle E and angle A is congruent to angle D, then I know those third angles are congruent. Very important theorem there. Okay, now, some of these properties that we learned about segments and angles also apply to congruent triangles. So, by the reflexive property of congruence, every triangle is congruent to itself. So, for instance, I could say triangle ABC is congruent to triangle ABC. Reflexive property. The symmetric property says if triangle ABC is congruent to triangle DEF, then I can just switch them around, right? And I can say triangle DEF is congruent to triangle ABC. And finally, the transitive property, if triangle ABC is congruent to triangle DEF and DEF is congruent to JKL, then I know that triangle ABC is congruent to triangle JKL. And you may need these properties sometimes in a proof. You never know. So I would make myself a flashcard for those, even though I didn't put them on your sheet. Okay, so that's pretty much it for the content of the lesson. I want you to pause right here and work these problems and come back and check your answers. Welcome back. Check your answers. The first problem, yes, the triangles are congruent. You can see my reasoning there. Triangle DEF is congruent to HGF. If you got any questions about that, please don't hesitate to ask me in class. The next two problems, I just got to pick out the angles that are corresponding. Since they're congruent, I know that their measures are equal, so I set those two equal. And for the first one, I get x equals 10. For this one, I get x equals 16. So pause there and look over that. If you didn't get the same answers, if you can't figure out where you went wrong, let me know in class. And finally, I want to know if these two triangles are congruent. And of course, all the parts are marked congruent except for angles F and Z. So by the third angles theorem, I know that those two are congruent, which means the triangles are congruent. So hey, everybody who checked your answers here, I want you to do something for me. I want you to write in your summary, the third angles theorem is my favorite theorem of all time. P.S. I love geometry. Okay, the reason I'm doing this, is because a lot of kids don't do these practice problems, and therefore, of course, they don't ever come back on and watch the rest of the video to check them. So when I come around and check your notes, I'm going to see who has this written down in the summary, and perhaps it's going to be a little extra point or so for you. So don't tell, because I want to see my trustworthy friends who are actually doing what they're supposed to be doing. All right, I'll see you next time when we'll learn some quicker ways to prove triangles congruent.